Hello and welcome, my name is Reinhard Partmann, and in this video we will talk about physical storage design for desktop pools. So let's get started. This is a really important topic. The reason is, well, we are running virtual desktops which are being consumed by our users, right? So and the users will complain if applications will not start in a timely manner or the whole system does not react, let's say, very snappy. And from that perspective, we need to design our storage. There are two key aspects we need to take care of. Number one, I already told that, performance. We will measure this performance in IOPS per second, and the second aspect is capacity. So let's dive into the properties what we have with desktop pools and how they relate to our storage key metrics. So what do we have on different types of pools? The different type of pools what we have are automated pools, manual pools, and remote desktop pools. Naturally, we aim to use automated pools because, well, like the name says, the pool is being created automatically by the system from a master image. Manual pools, not so much. Remote desktop session hosts are very versatile and they are very good to promote applications to many users. From the technical background, there are also different types of pools, and these types are more related how are the disk files of the virtual machines which are produced during the creation of a desktop pools made of. So we have full clones, linked clones, and instant clones. Like the name says, a full clone can also be an automated pool, but there is being created a full copy of the master image. However, it's thin provisioned, but yet there's a lot of data to copy. We have linked clones. These are created by the use of the View Composer, who needs a database. And they require less storage because they are all, like the name says, linked back to a so-called replica. Instant clones is the newest technology, the so-called new kid on the block. They are being created blazingly fast, much faster than the linked clones. They don't need a composer or a dependency towards a database. So when we can have the option, we are naturally going to the instant clones. Faster, lightweight, less storage usage than even the linked clones. But they only have one drawback. This is by design. When you log off, a linked clone is being destroyed. So you have to take care about this fact, because when a user is using his application, he's doing his stuff, he's doing his settings, prerequisites and configurations, and when he logs off, these settings would be gone. You would not accept that, I would not accept that, and believe me, users will never accept that. So you have to take care of the user persona. So when the user is going to log off, the persona is stored somewhere, and when the user is going to back log in into a new instant clone, the saved settings are being restored, imported into the systems, and ready for use. This is being done by the use of the VMware User Environment Manager. So now here we have a good list of benefits what we have when we are going to use the instant clones. As you can see, we also have a very good patch management because we are only patching one master. We have no boot storms because of the technology, how linked clones are produced, because they are being produced from a running VM by the process VM fork, and the running master VM which is running is called the parent VM. We are using very low disk capacity on that way, and they can be blazingly fast created. Here we have a slide where we can compare linked clones and instant clones. Like I said, linked clones are using the View Composer, and we have a couple of operations there: recompose, refresh, rebalance. On the instant clone side, it's just called create or delete. We can use the CRBC or the View Storage Accelerator for both of them. But the main big advantage of our instant clones is simply we do not have the View Composer and the Composer database. So one less service to care about, and this was a single point of failure in our View environment. Also, as the instant clones are using newer technologies for being created and stuff like that. They are blazingly fast, and if you imagine 2,000 virtual machines in around about 40 minutes, that's quite good. Also, the number of vCenter calls which are done from the Horizon environment to vCenter, who is actually responsible for creating our instant clones, are far less than when we are using linked clones. So now we talked about the different types of pools. The different types of pools also have sometimes different kinds of virtual disks underneath the destination virtual machines. If you have a look at the table, what types of disks do we have? Where are they usually stored? This all goes into a calculation of where do I have the storage? Do I have the necessary performance there, right? So you can split up sometimes the location of disks. Let's say you are going to use instant clones with a persistent disks and a disposable disk. So you can choose different data stores, storage locations, if you will, where those disks are being stored. Normally they are stored with the virtual machine, but you can and you have the choice to store it somewhere else. Depending on the size and the I/O metrics, the usage of the users, you need to take care of that those disks are filed on an appropriate storage who is able to handle the I/Os and also to have the capacity to store everything, right? On this slide here we have a formula, and if you look at the formula in the first line, it says we have a number of VMs multiplied by the percentage of the replica disk. This is when the delta disk is growing to a certain percentage of the replica disk, and then we add the memory of the VM plus 2 times the size of the replica disk. So let's say you have 10 VMs, like in this example, and 50% of a replica disk. Let's say our replica disk is in this case 10 gigabyte, so 50% of that would be 5 gigabyte. 5 plus 1 gigabyte of RAM, 6 gigabytes multiplied by 10 is 60, and plus 20 equals then out to 80 gigabytes. This would be then the capacity which is being used by 10 VMs, which are going to use 50% of the replica capacity. So you need to accommodate on a data store those 80 gigabytes. If you have less than 80 gigabytes free, you can't put 10 VMs on that, right? And always monitor your free space on your data stores, because a full data store wasn't a good idea, is not a good idea, and will not be a good idea. And I don't talk only on VMFS data stores or someone else. This is a general rule for file systems. So, storage optimizations, what can we do with that? Well, like I said, make up your mind where are you going to put all of your disk files. Think about it. Let's say instant clone replica disk. Most of these reads are coming out of the replica disks. So this is a hotspot for reads. So you might put this replica disk on a blazingly fast read storage, all flash for example. You have less reads and writes on persistent and disposable disks. So you can put those types of disks on a more cost-efficient storage. Enable the View Storage Accelerator, because this View Storage Accelerator basically is a RAM cache and it helps you with boot storms and read IOs. Here we have a small overview, roughly what you can gain by using the View Storage Accelerator. As the View Storage Accelerator is a read cache, you can see that reads are being optimized, and when there are many virtual machines on one ESXi hosts, all of those VMs benefit from the read cache because they get the data out of the memory of the host, and this is way, way faster than when they would access the disk subsystem. So, as a conclusion, I would say, do your math regarding performance, do your math regarding space capacity, and everything will work out fine.